In this worked example, we're going to calculate the maximum pressure a block can exert when resting on a table. This particular block is made of lead, and lead has a density of 1.13 by 10 to the 4 kilograms per cubic meter. And our rectangular prism has side lengths 12 by 15 by 10. All right, so. There's our block right there. Now we're going to rest to maximize pressure on the side that has the least area. So we'll start our calculation with pressure equals force over area. The force here is going to be the weight of this object. And so the weight is going to be mg. So we have mg over area. The mass is going to be calculated from the density. And so we can say that the density rho is equal to mass divided by volume. And so mass is equal to density times volume. The volume we're going to calculate as length times width times height. So lots of physics that goes into this particular calculation. I'll start with the volume. The volume equals length 0.12 meters times width 0.15 meters times height 0.1 meters. And so we want everything to be in meters, and so that we're getting a volume in cubic meters, because if you look at the units of density, it's kilograms per cubic meter. So when we multiply density times volume, we're canceling out these cubic meters to be in kilograms of mass. 0.1 times 0.12 times 0.15. You could probably do in your head and realize it's 1.8 times 10 to the negative 3 meters cubed. Or use a calculator if you want to. So we'll take 1.13 by 10 to the 4 kilograms per cubic meter times 1.8 by 10 to the negative 3 cubic meters. Now, the cubic meters are going to cancel once we multiply this by the given density. 1.13 by 10 to the 4. We've calculated the mass in kilograms to be 20.34 kilograms. So we have a lead block whose mass is 20.34 kilograms. We can assume this is here on Earth, where the acceleration due to gravity is 9.81 newtons per kilogram. And then we can see the kilograms are going to cancel, so we have newtons. Now the area that we want to substitute in is going to be this length times this width, right? We choose the lowest values because we want to maximize the pressure. So the least area. So it's going to be our 0.1 meter by our 0.12 meter face. So like this face has the least area. So if we rest our block on that side, right, then it's going to maximize the pressure. So we have 20.34 times 9.81. So it's about 200 newtons of force. About 200 newtons of force in the numerator there, divided by 0.1 times 0.12 is 0.012 square meters of area, to give a pressure of 16,627.95 pascals. So a kilopascal is 1,000 pascals. We move the decimal point over 3 or divide by 1,000, however you want to think about that. And we'd have this answer, 16.6 kilopascals. If you were to choose sort of another face and did the same calculation, like I think you did the 15 by 12 or something, you'd get 11.1 kilopascals. So that's not the maximum pressure then. We maximize pressure when we rest the block on the face that has the least area. And you can kind of see like these answers here, like this one's 1.7, kind of close, like maybe 1.6, like you round it. And so the fact that this one is off by an order of 10, maybe like you forgot to multiply by G. So like if you did this calculation and you're like, oh, good, I got the mass, and then just plug the mass in instead of actually calculating the force, which is the force due to gravity or the weight, right? Then you'd be off by about 10, right? Since G is about 10 on this planet. And so I imagine maybe you could arrive at like, you know, one of these answers by perhaps forgetting to multiply by G. So don't forget your physics, especially on the final exam. And remember to bring your calculator. There could be a calculator check. We'll see you next time.